The next topic is the applications of Euler's form, right? We have seen Euler's form. The next, we'll see its applications. Applications of fine. So now we know that if you want to represent a complex number, we need to consider the two values. The first denoted by x and the second one is y. Okay, x comma y belonging to the real group of real numbers, and say I is equal to root of -1. We know that we have all the different forms we studied so far. The first one is z is equal to x plus iy, right? This is referred to as the Cartesian. Okay, then we have this is also equal to the magnitude z into cos theta plus I sine theta, right? This is also you can write magnitude z angle theta, right? So referred as the polar. So this is polar, this is trigonometric polar. Okay, altogether you can call it as a polar format, and this is also equal to the magnitude of z into e to the I theta. So this form is what we call as Euler's. Okay, now the advantage of Euler comes into picture whenever we are taking the product and division of two complex numbers. All right, so first application is the product. All right, so let's say that we have two complex numbers, z1 denoted by magnitude z1 e to the I theta 1, and let's say there is another complex number, that is z2 is equal to magnitude z2 e to the I theta 2, right? We know that the theta 1 and theta 2 also belong to real numbers. Maybe in terms of radians it is pi by 3, pi by 6 real numbers, and in terms of degree 185.3, 188.9, all are real numbers. Okay, that's why it is belonging to R, and so the same I holds good here. This is root of -1. Okay, under such case, let's try to calculate a z1, z2. So this implies z3 is equal to z1 into z2. So this is nothing but z1 is magnitude z1 e to the I theta 1 into this is magnitude z2 into e to the I theta 2. So this is equal to, now I can multiply the magnitudes directly. This is z1 into z2, and e to the power any, if a number is raised to the same base, right, like e to the power something into e to the power something, it means you can actually club them together. This is e to the I theta 1 plus I theta 2. So you can see that this is equal to, totally this is magnitude z1 into z2. It's like magnitude z1 into magnitude z2. We'll write in that way, into e to the I times theta 1 plus theta 2. So this implies magnitude of the result is nothing but the product of magnitudes z1 into z2, and then the angle is denoted by uh, this is amplitude of z3 is nothing but whatever is here, that is e to the power I. We are expecting a theta over there. Instead of theta we have theta 1 plus theta 2. So this is nothing but the amplitude of z1 is theta 1 plus the amplitude, not amplitude, sorry, it's argument, right? Sorry about that. This is okay. Arg z3 is equal to theta 1 plus theta 2. So this implies it's equal to arg z1 plus arg z2. Fine. Then this is the first rule and first application. Then we have the second application coming up, which is the division of two complex numbers. Okay, so once again let's define. Let z1 is equal to magnitude of its value into e to the I theta 1, and z2 is magnitude z2 e to the I theta 2. Right, now if you call a function z3 is equal to z1 by z2, it is magnitude z1 e to the I theta 1 whole divided by magnitude z2 e to the I theta 2. So by definition, right, the magnitudes are the real values you can divide. So this is equal to magnitude z1 by magnitude z2 into e to the power, you have I theta 1, and denominator will go to the numerator as negative number, so this is minus I theta 2. So as a result, now this is equal to magnitude z1 by magnitude z2 into e to the power I times theta 1 minus theta 2. Okay, so this is the z3. So this implies if you want to calculate a magnitude of z3, then this is equal to simple magnitude of z1 and magnitude of z2. And the argument. So this is arg of z3 is always equal to theta 1 minus theta 2. So theta 1 minus theta 2 corresponds to argument of z1 minus argument of z2. Okay, then we have the third application of this particular form, which is called as a log, taking a log. This is logarithm of complex. Okay, so we know that. So let that is z is equal to magnitude z e to the I theta, right? So this means if at all we want to take log z, then this has to be log of magnitude z e to the I theta. It's a product. Log of product is nothing but there is a rule which is log of a product is sum of logs. So this is log of magnitude z first term plus log of this is e to the I theta. Alright, so this is equal to log z1 remains as it is. We do not change this. This is log of magnitude z as it is plus, see, whenever something is raised e to the power or a to the power b inside a log, the power comes out, that is I theta into this is log of e. So normally this log is called as log to the base e. Log to the base e of e is, this is 1. Okay, so this means it is simply log of magnitude z. Anyway, remember this is to the base e plus I times theta. Theta is nothing but the argument of z. So whenever a complex number z is given and we are asked to find its log, then this is the way of representing that. So log of a logarithm of a complex number is also complex. Okay, now let us try to solve some basic problems. Okay, first one, this is z1 is equal to 8 minus 3i. z2 is equal to 1 minus 2i. Right? So using the Euler's form, find the find z1 into z2 and find z1 divided by z2 and also find z2 by z1. Okay, so we know that if we want to find the z1 into z2, it has to be magnitude of z1 into magnitude of z2 into e to the power I theta 1 plus theta 2. So I need to find both of them, right? So z1 is given 8 minus 3i. So when z1 is 8 minus 3i, this implies calculate magnitude of z1, that is root of 8 square 64 plus this is 3 square 9. Okay, so this comes to be 8.544. Let's calculate theta 1. As per the rule, this is equal to, I can see that the angle of this is 8, x is positive, y is negative, right? So this has to be in the fourth quadrant, right? So this has to be tan inverse of 3/8. Okay, you can write in degrees, no problem. If you take this tan inverse of minus tan inverse of 3/8, that comes to be minus 20.5 degrees. Okay, so similarly, let's calculate for Z2. Z2 is equal to 1 minus 2i. So this implies magnitude of Z2 is root of 1 plus 4. So that is root 5 2.236, and angle theta 2 should be, this is also fourth quadrant, so minus tan inverse of 2. So the angle comes to be minus 63.43 degrees. Okay, so using them we can calculate the required answers now. So if you want Z1 into Z2, this should be equal to magnitude Z1 into magnitude Z2 into e to the power I times the theta 1 plus theta 2. So magnitude Z1 is 8 point okay 8.544 into 2.236 into e to the power I times, so substitute theta 1 minus 20.5 and the second number is minus 63.43 degrees. So this is equal to 8.544 into 2.236. This is 19.104 into e to the power minus I into, so this is 20 and 63. This is 83.93 degrees. That is Z1 into Z2. Then let's go further. The question is to find Z1 divided by Z2. That is magnitude Z1 by magnitude Z2 into e to the power I theta 1 minus theta 2. So magnitude Z1 is 8. This is 544 divided by 2.236 into e to the power I. So theta 1 is minus 20.5. Sorry. And theta 2 is minus of minus plus 63.43 degrees. So this is 8. This divided by 2.236 is 3.821 e to the power I. Now the calculation is minus 20.5 plus 63.43. So that is I into 42.93. Okay, this is how you calculate Z1 by Z2. Then the question also asks to calculate Z2 by Z1. This is magnitude Z2 by magnitude Z1 into e to the power I times theta 2 minus theta 1. So that is minus 63.43 theta 2, minus of minus is plus 20.5. So Z2 by Z1, this is equal to 0.261. Now we have, this is 20.5 minus 63. So the answer becomes just negative in the power e to the minus 42.93. I times 42.93. Right. Now we'll problem for you to solve is this. Okay. Z1 equal to 6.5 plus I 3.2. Z2 is equal to minus 1.8 plus I 3.95, and Z3 is equal to minus 2 minus I into 3. Right? Calculate. First question is Z1 into Z2 into Z3. Okay. Then calculate Z3 by Z1 into Z2. And the next one is Z1 Z3 by Z2. Same procedure. We need to multiply all of them together. So Z1 into Z2 into Z3 can be written like Z1 magnitude Z1 into magnitude Z2 into magnitude Z3 into e to the power I theta 1 plus theta 2 plus theta 3. Okay, first ಗೆ magnitudes calculate ಮಾಡಿ ಇಟ್ಕೊಳ್ತೀವಿ. ಅದಾದ್ಮೇಲೆ theta 1 theta 2 theta 3 ready ಇಟ್ಕೊಳ್ತೀವಿ. Okay, then according to the given question, right, you substitute and calculate their values. Okay, Z1 into Z2 into Z3 is equal to 1 1. Okay, 0.337 into we need e to the power I equal to I times tan inverse of the first number. This is tan inverse of 0.492 pi minus tan inverse 0.194 third angle plus pi plus pi 2 pi ಬರೋದ್ರಿಂದ you can write 2 pi here, right? Correct. Tan inverse of 1.5, yes, is the answer. All right. Doubt ಇದೆಯಾ ಏನಾದರೂ? ಹಾ, 0.114 into e to the power I times, okay, pi plus tan inverse 1.5 minus tan inverse 0.492, okay, tan inverse 0.194. So ಇಲ್ಲಿ pi minus pi cancel ಆಗುತ್ತೆ. Remaining terms you can simplify and write the answer. Correct? Okay. 6.017 into e to the I 0.492, okay, pi plus this is tan inverse 1.5. So pi pi cancels again. Remaining terms you can write as the answer. Okay. Next question is, this is to find the log of, this is 6 plus 8i, right? So we know that this is a question to calculate log of z, right? So z is equal to 6 plus 8i. Convert this into magnitude z and theta first. Okay, calculate magnitude z and theta. Okay, magnitude is 10, then tan inverse of 1.33. Okay, now if we go back and check the rule to find the log z is equal to log to the base e of magnitude of z plus I times argument of z, right? So let's write the rule. This means log to the base e of z is equal to, this is log to the base e of magnitude z plus I times simply theta, okay, argument. So just write that. This means you need to calculate log to the base e of 10 plus I times tan inverse of 1.3, right? So ನಮಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋ ತರಹದ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಬಂದರೆ ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ರೈಟ್ ದ ವ್ಯಾಲ್ಯೂ. This needs calculator, right? Scientific calculator ಅಲ್ಲಿ log to the base e, log to the base 10 ಎಲ್ಲ ಇರುತ್ತೆ, right? We can calculate that. Otherwise, if that is not possible, give the answer as it is. Okay, all right. Let's write next one. So this is same thing. This calculate log of, this is -8 plus 4i. 8.944 5 times pi minus tan inverse of 0.5. Correct. Okay, next one. Log of this is minus 3.5. This is minus j9 to log 9.656. Both are negative, right? Minus 9 and minus 3.5. So this means it is in the third quadrant. So pi plus in the barvakala. Okay. 2.571. Yes.